Measures of position. And let's talk about what we're going to do in this section. And this is basically what you should learn. So we're going to learn how to find the first, second, and third quartiles of a data set. We're going to talk about how to find the interquartile range of a data set, how to represent a data set graphically using a box and whisker plot, and how to interpret other fractiles such as percentiles. And we want to find and interpret the standard score, in other words, the z-score. Okay, now, what does fractile mean? That's what we need to talk about before we do anything else. Fractile is the term used generically to discuss breaking a data set into discrete sections or groupings. Fractile means fraction of, okay? So if I say we're going to talk about quartiles, quartile means that I'm taking the group and breaking it up into 4 equal groups. Percentile means I'm breaking it up into 10 equal groups. And those really are the two main fractiles that we will discuss, are quartiles and percentiles. So let's define quartile. You already know what one of the quartiles is because we've discussed it. But the 3 quartiles, Q sub 1, Q sub 2, and Q sub 3, will approximately divide an ordered data set into 4 equal parts. About 1/4 of the data will fall on or below the first quartile, Q sub 1. About 1/2 of the data fall on or below the second quartile, Q2. Now, this is what I was trying to say, that you already discussed this. The second quartile is the same as the median of the data set. So when we use StatCrunch to find the quartiles, it's not going to give you Q sub 1, Q sub 2, and Q sub 3. It's only going to give you Q sub 1 and Q sub 3 because it will give you the median. And you're going to assume that's Q sub 2. About 3/4 of the data will fall on or below the third quartile, Q sub 3. We don't necessarily call it Q sub 4, but does it not follow that 100% of the data will fall on or below Q sub 4, which would be the maximum data value? Okay, we don't really discuss it, but that's kind of what you need to have in your head when you're thinking about quartiles. Now, how do I go about doing this? Well, quartiles, let's look at, yeah, we'll go ahead and use this one because they've already got, and we're going to do another one. Okay, finding the quartiles of a data set. The first thing I want to do is go ahead and order the data set from least to greatest. You have to do that. Okay? So order the data set. And that would give me 6, 7, 8, 10, 11, 15, 17, 18, 18, 19, 20, 31, 54, 59, and 104. So I've just ordered it from least to greatest. And then I'm going to find the median, which in this case is right here. That's your median. That also happens to be Q sub 2. Okay? Now, what you want to do is you want to then look at the lower half, and you also want to look at the upper half to find Q sub 1 and Q sub 2. So if this right here is Q sub 2, okay, I'm going to look at the lower half and I'm going to look at the upper half. And then I'm going to find the median of each one of those halves. So Q sub 1 is 10. Because that's the median of the lower half. And then I want to go ahead and look at the upper half. And in this particular case, the upper half, the median, or Q sub 3, is 31. And remember that Q sub 3 is the median of the upper half. Now, for a small distribution, finding quartile 1, 2, and 3, not that difficult. But when you get into a distribution that has 300 or 400 data values, finding Q sub 1, Q sub 2, and Q sub 3 becomes a whole lot more labor intensive. Okay? Now, before we move on, let me just write it in this format. So obviously I want to have some way of finding the quartiles that doesn't cause as much labor, okay? And we're going to use StatCrunch to do that. But before we do that, let's define the interquartile range. The interquartile range, the IQR, is, where do they have their definition? There it is. The interquartile range, as I said, the IQR, that's what it's called, is simply the difference between Q sub 3 and Q sub 1. It's a measure of variation that gives a range of the middle 50% of the data. It is the difference between the third quartile and the first quartiles. So the IQR is simply Q sub 3 minus Q sub 1. So if that's the case, going back up to this problem, the IQR is simply equal to 31 minus 10, which is 21. Okay? And that's it. And that represents the middle 50% of the data. So let's look at that real quick in terms of the data. Oops. So right here, we have the median, which is Q sub 2. Right here, we've got Q sub 1, and then right here, we've got Q sub 3. And the interquartile range is this, 31 minus 10, which is equal to 21, and that is the middle 50% of the data. And that should make sense, because if I look at this, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 data values right there. Outside of this thing, I've got 6 data values. This whole thing is really where I want to concentrate. The stuff that's going to outlie, and they are outliers because let's look realistically, especially at these numbers, these are very different from what's in the interquartile range. These not so much, but they are outliers. A lot of times an accurate picture can be developed by looking at the interquartile range and looking at the data values in there, which means that my calculations become a little less painful. Now, using computers to do all this stuff is not so bad anymore. Okay? And let's go ahead and look at that real quick. Let's just go ahead and jump into StatCrunch. Actually, yeah, I'll use that one. Okay. All right. We've got this column right here. It's got a bunch of data in it. I want to go ahead and find the quartiles and the interquartile range. Go to Stat, go to Summary Stats, and go to Columns. I want to go ahead and use this first column because that's the one I'm looking at and click Next. Now you'll notice that I have just selected median, Q sub 1, Q sub 3, and IQR. And if I go ahead and click Calculate, it gives me that information. Here's Q sub 1, Q sub 2, Q sub 3, and the interquartile range. Just like that. And you can copy the data straight out of my stat lab and you're done. Okay? What's the matter? Why am I showing you the hard way and then giving you the easy way? It is. It really isn't that hard. And most of the stuff that we do in this course in the first couple of chapters aren't that difficult. They're just time-consuming, hugely time-consuming. And for a long time, mathematicians considered statisticians to be the bottom dwellers of mathematicians because what we did was what they called grunt work. Okay, and we just took the numbers and we crunched the data. We weren't trying to do fancy curves and stuff and find out what the velocity of something at a given time is in 3 space. We're just taking a whole bunch of data and trying to figure out what the pattern is. But using computers nowadays, it becomes so much easier. Okay? Now, the next thing that we're going to talk about, and I believe we have time, is talking about drawing a box and whisker plot. A box and whisker plot is a 5-number summary using a graphical interface to go ahead and describe the data that we're talking about. Come on. There we go. So let's look at the guidelines for drawing a box and whisker plot. Like I said, you want to construct a 5-number summary. You're going to construct a horizontal scale that spans the range of the data, meaning your minimum entry is here, your maximum entry is here. Then you're going to put in your Q sub 1, you're going to put in your median or Q sub 2, and then you're going to put in your Q sub 3. And then you're going to draw a box around the interquartile range. The whiskers are the stuff to the right of the box and to the left of the box. Hence the reason it's called a box and whisker plot. And that's all there is to it. Okay? Now, let's just look at the data set that we were using. Let me get rid of this because we don't actually need it. Let's look at the data set that we were using up here. Okay. How do I draw a box and whisker plot for that? Well, what's the minimum entry for this thing? Well, it's 6, right? The minimum entry is 6. Then this value is 10. This value is 18. This value is going to be 31. And then the maximum value is 104. And obviously you want to try to draw the box to scale. This whisker should be really long because we're going from 31 to 104. Okay? So you want to draw this thing to scale if you can. You want to try to draw to scale. Tell you what I'm going to do. Let's go into StatCrunch and let's do a new column. And I'm going to go ahead and put the data in that we've got. Okay. This second column, this represents the data that we're using okay. This is the data that we've been using. So data from the example. We already know that Q sub 1 is equal to 10, that Q sub 2, or the median, is equal to 18, and Q sub 3 is equal to 31, and that the IQR was equal to 21. We already know that. But let's assume that we don't. Now let's say that I say, from the given data set, draw the box and whisker plot. And I'm going to do that by hand. Well, I don't want to do it by hand. I'd much rather do it by using StatCrunch. So I'm going to come into graphics, and you're going to see box plot, I believe, is the one we're looking for. Yeah. Let me just double check and make sure.